So I've created a Systems of Equations digital interactive sorting activity. And the first thing I need you to do is go to the top, File, and you need to make a copy so that you are doing this on your own and you can edit it on your own. So the purpose of this was to kind of go along the lines of still in that introduction mode of what a system of equation is and linear lines that we've been working on for a really long time, just connecting that to their point of intersection and also what that looks like on tables. And so just a little bit more practice with it conceptually. So you are going to match and type the correct slope and the y-intercept for each linear equation on slide 3. And then I break down again, okay, so what is the slope, what is the y-intercept, and you're going to go to slide 3 when you make your own copy of this first. And you should be able to just click and type in the text, referring back to slide 2, and you could just, instead of writing the actual slope, you could just do A, B, C, D, and so on. Then when you're finished matching the slope and the y-intercept, the tables you can actually manipulate and move. I want you to move the correct tables to the linear equation that it belongs to. So I'm going to kind of clarify that a little bit more. So remember, linear equations are like rules. It's what you're doing to the inputs in order to get the outputs. So I'm going to look at the first one. And so the rule in words is I'm taking the inputs, I'm multiplying them by -3, and then I'm adding 1 in order to get the outputs. So you're going to look at each one of these tables and you're going to try and figure out which one of those rules is correct. So there's a couple ways you could do it. You could do it algebraically. So if I'm looking at table D, if I'm looking at the first x value of -1, if I take -3 and multiply it by my input of -1, and then if I add 1, simplify that, so that would be 3 plus 1, I get an output or y of 4, which is not this. So this is not going to be the correct table. Okay, that is one way to do it. Another way to do it is to kind of focus on the y-intercept, which in this scenario is 1. And remember, the y-intercept is always written 0, a number. So you're looking for 0, 1 in one of these tables. So that is another way you could do it. And then on the fourth slide, you're actually going to graph these individual linear lines. And so just going back, we've been doing this for a while. If you need to refer to Desmos.com to check, that's okay. Remember, you have to start on the y-axis and figure out what the y-intercept is. So for the first one, it would be 1, so I would be starting on the y-axis at 1. My slope is -3, so rise 3, go to the left 1. Just draw some real simplistic linear lines. You could actually use the line tool just to the best of your ability. I would actually probably just make a line and just kind of move it so you can get the correct slope and all that. If that is too difficult, you could grab some paper and you could just hand do the graphs if it's too tricky using these tools. Then on the very last slide, this is trying to connect it all. It says which linear equations share a common solution. So you're going to refer back to slide 3 after you've kind of sorted them to their correct linear equation. And you're going to look, remember these are ordered pairs, and you're looking for any ordered pairs that these tables have in common. And you're going to kind of list them there. That's a very, very special purpose. They share the same x and y. And then we're going to focus on 2 of these specifically, and we're going to draw them on the same graph. And you can use this graph right here if you want to use your own graph paper, and then answer these questions. The ordered pair, do they intersect at, the coordinate, you can just type it in. And then what is true about the point with regards to each of these lines right here.